Okay, okay, sir. Right. Yes, I think yeah, we can go ahead and start. Can you hear me? Am I audible? Yeah. Okay. Okay. Right. So good afternoon, everyone. Kindly follow the webinar rules. Please keep your mic muted at all times, and to avoid bandwidth issues, I also request you to keep your cameras off also. Right. So, my name is Koshi Joseph. I am working as an assistant professor in the Department of Automobile Engineering, and I'm also the faculty advisor for the SA India Collegiate Club of SEMS. A brief introduction about the department for our guests and visitors from other institutions. The Department of Automobile Engineering was established in the year 2004. The department currently offers a UG program with an intake of 60 students. To update with the recent trends and developments in the field of automobile, the department takes up the initiative to conduct various seminars, conferences, and workshops with eminent speakers from reputed academia and industry. As part of this initiative, I welcome you all to this webinar from product conception till start of sale, various stages of automotive product development, organized by the Department of Automobile Engineering in association with SA India Collegiate Club of SEMS. Today, I have the pleasure of introducing Mr. Don Kurian, who is joining us from the automotive capital of the West, Detroit. Mr. Don Kurian completed his BTech in Mechanical Production from TKM College of Engineering, Kollam, Masters in Engineering in Automation and Manufacturing from University of Pune, and he also has a Masters in Motorsports Engineering from the University of Derby, UK. He started his career as an auto journalist in a prominent auto magazine in 2009. In 2010, he joined Mahindra as a trainee and has been with Mahindra till 2020. During this period, he worked in various roles as a vehicle test engineer, deputy manager in vehicle valuation and diagnostics, and also in technical documentation and after sales support. He is currently working as a validation engineer with a reputed OEM in US. So, welcome, sir. And I like to also just briefly mention to our students, please keep this session as interactive as possible. Let our guest also be comfortable with you, and we will try to finish this session as quickly as possible. And welcome, Mr. Don Kurian, and I hand over the mic to you to start the session.
customers, how what all features it should have. Based on all these inputs, they would
കോശാരെ പുള്ളിയുടെ പ്രസന്റേഷൻ കാണാൻ പറ്റുള്ളല്ലോ.
Yeah.
This is how they do virtual validation. You could look at the we could define a stress point on the vehicle, and then the load would be applied over there, and these softwares would help to understand whether how the stress is traveled across the panels, or components, and how this is going to fail. Like, say, if you are going to give this load for 100,000 cycle or 200,000 cycle or 1 million cycle, when is the failure going to happen, or which part of that particular system is going to fail? That is, these tests are being done virtually, and then the design is tweaked to a stage where we are sure, okay, this is right now quite good, and then let's start making prototypes. So what is prototype is, prototypes are the early models, not the final production model, but the early models which is being developed to check the design. There would be actual fitment trials. So once these prototype or components are developed, there would be fitment trials and see whether actual. So you could draw something in CAD, and it is not that easy to develop the same component in real life. So you go to a machine shop, you give this design, and some designs are simple, so they will make it very easily. But sometimes it would be really difficult to make. So they would come up with a different suggestions. So there would be back and forth talking between the design engineer, actual prototype manufacturer, and there would be manufacturing team involved in this stage as well, because how would you develop a vehicle if it is not manufacturable? There is no point. And the manufacturing, most of the time, you would definitely have a manufacturing facility at that time. Like say, okay, you are going to develop a new vehicle, and if that vehicle is manufactured in an existing current line, then it needs to meet certain requirements. So during this engineering, design, and drawing modeling time, you have to make sure that okay, this meets that requirement. Say for example, I'll tell you. If you're planning to manufacture a vehicle in the same line with another vehicle, then the track width, the difference, the width between the tire, the left and the right tires. Okay, most of these vehicles will be moved in a pallet across the line. So manufacturing line will be very long line. So there will be a fixed track width, and if you try to give put a vehicle in the same line which has a different track width, it would be difficult to manufacture, because then you would need two size of trolleys where this could be pushed forward. So this is a very difficult task. So when you plan a vehicle and you want to manufacture that same vehicle, that new vehicle on the existing line, then the engineering constraint would be okay. Then you should have a similar track width, so that this could be made across, and the overall size, so that because you use the same tools for manufacturing this vehicle and that vehicle, and it is not like you make 100 vehicles of this and then you make 100 vehicles of that. Sometimes you would have one by one. There would be one, for example, there would be one Scorpio, and then there could be one Silo. So these could be going one by one. So the design. So what happens is mostly there would be a platform. So you would most of the underpinnings of the vehicle, like the chassis, suspension, engine, this is what we call a platform. So these would be common for a same platform. So they would be remaining same, and only the body would be changing. So in that case, you could accommodate these two vehicles, even though they look different entirely from outside. They could be manufactured in the same line. So the engineering team has to be brilliant enough so that they consider all these points. Then let's talk about prototypes. So I believe you guys have seen pictures like this online in automotive magazines, or probably on the road in real life as well. So what are these? So these are vehicles which are made long back. So like say if the vehicle is going to launch in say in 2022, you might find vehicles with these sort of camouflage. The design of the vehicle is called camouflage, with camouflage running across streets. So what are these for? So these are made once you come up with the design. We wanted to see whether these vehicles are good, or if how this actually feels on the real life. So that's why prototypes are made. Prototypes are actually not made in the manufacturing line. There is something called a proto shop, where they would get components one by one. They would assemble it each vehicle separately, and these vehicles are manufactured in a very long time. So sometimes especially the initial prototypes will take more than a month to manufacture, because you will have some components coming in and it doesn't fit in. So we have to tell the supplier that okay, this is not fitting, so you have to change the design change. So this could be a very long process at the beginning. Once you have the design sort of finalized, then the next vehicles, again, these would be handmade, and then they would be much faster. But again, in a normal vehicle, you could do the manufacturing in say probably in a couple of hours. But whereas a prototype will take long time to manufacture, and all the vehicles are not the same. That is the main important part of prototypes. So prototypes are made for a purpose. So some vehicles would be made for fuel efficiency testing. Some vehicles would be made for crash testing. Some vehicle will be testing for durability testing. So each vehicles, they will have a number, and these vehicles would be made specifically for that particular purpose. Say for example, components which are fitted on a proto vehicle is very expensive, since they are not mass manufactured. Each component would be very, very expensive. For example, a headlight in an early prototype. Most of the headlights we know, if you go to a dealer and buy a headlight, it would cost maybe between 5,000 and 10,000 rupees. But a prototype headlight could cost up to 10 lakh rupees. So, a proto vehicle, once it is manufactured, it would cost in crores. So I know this might be might sound funny, but yeah, that is the actual cost, because most of the components would be either made specifically by the supplier and the manufacturer just for the prototype. So there is, instead of they would be making this one component where they would be doing 100 components if they would have mass manufactured. So the cost is really high during prototype time. So they make very few numbers of prototypes, and all these prototypes, they are not made with completely functional. They would be if you're only doing it for say suspension testing, okay, you will make that vehicle suspension as good as you can, but rest of the interior seats may not be really that great. So but because you're only looking at suspension of that vehicle, there would be vehicles which are made for engine testing, so the engine would be in a really updated stage. Everything else would be in a very maybe in a lower level. There would be a lot of fitment trials happening, validation and testing. This is again very important stage. Validation, so we have a design developed through CAD, which is a virtual world, and then you had a simulation done in the virtual world, but we don't know how, if that vehicle is manufactured by a team, how it is going to be in the actual world. So that's why we develop. We have to do validation and testing on that. So there is 3 different stages of prototypes in general. There are multiple stages, but I would just be in a very simple word, we could say it as 3. Mule is a very early stage, and then there is something called validation prototypes, and then there is production prototype. Mules are sometimes say you are coming up with a new engine or for a new vehicle. So there is a new platform which is going to come in 2025. So I hope you guys know that the engine is one of the early lead items which would be manufactured much earlier. If it is an electric powertrain, these driveline components are especially since the validation is a very long process, these systems would be made much earlier. So what they does is they will have the motor and the battery or the engine already ready by right now, but the vehicle would be none of the other parts are ready right now. So what they does is they will put these components in another vehicle, maybe like say there is a vehicle already right now. So you put that, you modify that vehicle, put these components in that vehicle, and then do testing and see how this thing is performing, and then they'll try to improve and see how the reliability is. So this is what is called a mule. So the mule is actually a makeshift vehicle with some components in it which is going to be new. Then there is validation prototypes. Validation prototypes normally happens after the complete prototype build starts. So these vehicles would mostly look like the new vehicle. They will have the engineering of the new vehicle. They'll have most of the components new, but it is not actually that it may not be true that this vehicle have all the components of an actual manufacturing production vehicle. So that is validation prototype. So they would be these are the ones which are made for the purpose, but most of them are made. Almost 90% of the contents in it, where it should be with the final. But the important part is these are not made in the exact manufacturing process. Say, for example, you wanted to make a bracket. So for the final production, you are planning to use MIG welding. But like in the supplier should have a jig where they will be fixing the component on that. They would be welding on that. There would be a set welding voltages and the current and the speed defined. But whereas in a validation prototype, this may not be the right thing. There would not be any process. So you would give the design to the supplier and would ask him to make the component. So he would be making that component one-off. So the process of how that component has to be manufactured is not defined at most of the validation prototype vehicles. So you would see failures at that time, and then this is the stage where the engineers would define the process of how that has to be manufactured. Production prototypes are prototypes which are made in the actual manufacturing line, following the actual manufacturing process. Again, once you make the prototypes, only then you will know the flaws of that process. So, what all difficulties are happening, what all sometimes you will find a lot of issues or irregularities when you actually make the vehicle. So these are test in production. So how the production process works by making some prototypes. Then testing and validation. I'm going to go a little faster here because we don't have much time. There is not much slides left, but again, I would like to show you a video, maybe at the end. Testing and validation. So there is a lot of different types of testing which needs to be completed before the actual vehicle is given to the customer. So you need to do performance testing. Performance testing could be, road acceleration test, brake test, steering performance, gradability. There are a lot of tests just to see whether the performance is reaching up to the stage where we have set the target. So like I said before, during the first stage of engineering design was setting the target. So now during the testing stage, these would be verified whether we actually meet that target. Then there has to be quality control. Then durability is defining the life of that component. So before this vehicle is while the vehicle is designed, there would be a defined life, like say, okay, this vehicle has to undergo in India it has to undergo 2 lakh kilometers. So the component has to withstand 2 lakh kilometers. So each and every component has to be designed based on that life. So and then the durability is the testing which is done to make sure that these components actually last that long. So there are if the actual prototype for testing is manufactured, say, an year before the vehicle is launched, there may not be time to actually run this vehicle for 2 lakh kilometers and see whether what fails at what kilometer. So what does is there would be accelerated durability testing where the vehicle would be going through a cycle. There is a cycle where you would be actually driving only 50 kilometers in a track. The track has so many different types of potholes, steps on through it, and the vehicle would be driving through that. And this gives you a very high amplitude inputs to the suspension and the components. And so this 50 kilometers would give an actual road driving equivalent of around 1,000 kilometers. So you are just by driving 50 kilometers, you will see what are the failures happening in 1,000 kilometers. So by that way, you could do accelerated durability testing. There are different types of system level testing as well. Like, say for example, engine, you don't actually have to drive on a vehicle and see how it fails. You can put it in a dyno and run. There are different cycles defined by the team, systems engineers. So based on that test, you could complete 2 lakh kilometer testing in say 1 month. And that is how we define, okay, this engine is good, and now we put it in the vehicle and it will not fail. Then another most important testing phase is called certification. So before each vehicle is launched in any country, it has to undergo certain test defined by the government agencies. So in India we call that CMVR. So the CMVR test has to be passed. There are a lot of testing. I think there is around the total cost. So we have to take this vehicle to a government test center like ARI, VRD in Ahmednagar. There are a lot of testing centers right now, and there are set parameters defined by these agencies regarding performance. One simple example is emission. So we know that there is Bharat Stage 6 emission which has been applicable in last year. So the vehicle has to meet that emission standard. So this emission standard, whether it is meeting or not, we have to take this vehicle to a test center, which is right now there in different locations in India. So you take it over there, they will do the test for you, you pay a fee for that, and then they will give you a certificate. So that's how this certification has happened. Certification is very important because once the vehicle is completely certified, only then you can launch that vehicle, or only then you can start the sale of that vehicle. So if you buy that vehicle, you go to an RTO office, the RTO should already have that copy of the certificate which is been given by the test center. So if the RTO doesn't receive that certificate, then he will refuse to register that vehicle in that particular RTO office. So this is also very, very important. And as far as I understood, it would cost up to 1 to 2 crores of expenses to complete this testing in this testing centers. There are different types of testing. Crash test is a part of that. There is seat belt testing. There is visibility testing. There are a lot of testing in that. Maybe we could do another session some other time regarding these testing. again, so the testing we are dividing that into three. The benchmarking is where you would get the target customer vehicle, define the target. Then development is where you have the validation vehicle, where you check whether everything meets, and certification is the vehicles which are very close to the final production vehicle, and they would be sent to the government test centers, and then they would certify that vehicle. So these are the three stages in the testing and validation phase. Then the calibration and the tuning. So I know you guys have seen a lot of vehicles before launch on the road. So most of these vehicles are actually taken out for calibration and tuning. So there, for example, there would be different vehicles, different type of vehicles with having the same engine and the gearbox. Say for example, you have Maruti, Suzuki Swift having a same engine. You would have Ertiga having a very similar engine. But these two vehicles are made for two different type of purpose. So the calibration is how you define or change the tuning of that engine to fulfill the requirement of that particular set of customers. So this is a very long intuitive process. So you have to take this vehicle. Most of the calibration would take around 6 months to 1 year. So this is not only for the engine. We have to do it for suspension as well. Suspension, steering. So like I said, to manufacture the same manufacturing line, you would have to have the similar components in that vehicle. But sometimes these vehicles would be defined for different market or different type of people. So these people would be loving. Some people would be would like to have a sporty driving vehicle, whereas other would be liking a very easy steering. So if it is an electronic power steering, it is much easier. You can just change the cal file. Cal file is the software file which we load into that particular ECU on that particular vehicle. And once we change the calibration, this same steering would feel two entirely different way. For example, we have two Mahindra vehicle. Mahindra Marazzo and Mahindra XUV 300. So these two vehicles, one is a mass market taxi vehicle, the other one is a personal vehicle. So these two vehicles have the same engine in that, but they drive very different, because the XUV 300 is a sporty vehicle, personal customer vehicle. So when you press the accelerator pedal, it is much sportier. It has very much better accelerator pedal response, whereas Mahindra Marazzo is taxi vehicle. So you would mostly looking at the customer, taxi would be driven by a customer driver, and there would be customer sitting at the back. So it is mostly designed for comfort. So this is how you have the same engine, but you have different calibration, and then tune it for the different customers. Brakes, seats, even so these calibration would be doing probably at the later part of the development. So you will have an initial calibration, and then the people will be fine tuning it based on jury drives. So there would be a team of drivers within the team. There would be senior drivers. There would be gateways. So there would be different stages within the manufacturing process where the vehicle at that level, these jury drivers will drive, and they'll rate. Okay, this seat is not as good as the target, and then it has to be improved. So the people would be changing. The engineer would have to change the seat cushions and adjust it so that it is very comfortable and meets the target. MMI is multimedia interface, the stereo system which we have. So there is a lot of calibration and tuning. You will have the same screen. You might have the same screen in different vehicle, but they will look different. They'll have a different interface. These are the small calibration and tuning happening, and this happens this happens from the beginning. But the calibration tuning is very important, especially these are the fine tuning which you see at the very end of the manufacturing process, at the very end of the engineering process. So this is a very small example of how a product development process. So this is not any of the process. This is not the process which is followed by any company. This is a very generic process which I downloaded from the internet, because most of the companies doesn't allow to share their product development process outside the company. So that's why I'm not able to share anything from the companies where I work. But this is something we can. But this again shows a very clear idea. So the one you see below is kind of give an indication of the timeline. So this 36 is months. So you can see this is where the program management is a team which, like I said, there is styling, there is market research, there is engineering, then there is manufacturing. So the program management is a team which coordinates the entire timeline of the process. So when the styling has to finish and give out their output, when the engineering has to start, that is being controlled by the program management. Their role is simply managing the program. And once we have a product definition, then the engineering would start developing the concept and then design. There would be virtual models developed, and then once the models are developed, there would be simulation. And then by this around 26 months before, there would be prototypes manufactured and there would be testing going on. You can also see that the production manufacturing is also started much by the time when the production, when the engineering is actually been started. So the manufacturing team would define where this has to be manufactured. Then whether there is a new plant has to be manufactured for that. Then how the logistics from where suppliers, where all they are coming from, whether it has to go for a just-in-time manufacturing, or whether you need to make a warehouse where you store the component and then you get the components from there. So all these parameters are defined very early on. Then only you will be able to launch the vehicle at the SOP. SOP is the start of production. One another important feature which I'll talk in the next stage is the defining the manufacturing process. So manufacturing also starts with the product planning. So when the product is defined at the beginning, there would be a team of manufacturing engineers who are working and thinking about how this can be manufactured. And no product is going to be kicked off unless the manufacturing plan is set. Because if there is no manufacturing plan, there is no point of developing a vehicle, because you cannot manufacture and sell the vehicle. So manufacturing is very important. There is something called product kickoff. So like I said, once the conceptualization stage is complete, there would be a product kickoff. That is called a gateway. So at that particular, there would be a lot of reviews meetings happening, and then the senior company management will say that, okay, you can start manufacturing. We are going to give you $1,000 rupees for this project. So at that stage, there would be engineering design kickoff, and there would be manufacturing facility development and preparation kickoff as well. So one of the important factor here is that based on the stages which I showed before in the engineering design, there is a gateway called tool kickoff. So tool kickoff is once we are into the validation, we develop some vehicle, we do testing, and then we understand, okay, this design is good, this is okay. So we have to tell the supplier that, okay, we are okay with this dimension and this process, so you can finalize that. So he will have to make jig. Sometimes he might have to buy new robots or stuff. So that is called a tooling kickoff. So the supplier, whether it is being manufactured outside the company, whether it is manufactured within the company, that manufacturing facility will have to be finalized. So they will have to make dies, they will have to make tools, they'll have to make jigs for that particular production. So once that is being kicked off, that is where the actual mass manufacturing production can be started. There would be production tryout. So each vehicle, I think probably less than 25% of the component is made within that company. So rest of the components, the OEM buys it from different suppliers. So different suppliers makes components very differently, and we have to make sure that, okay, they all fit together, and in a manufacturing facility, in a manufacturing line, they can be there would be a defined takt time for each station. So you can see each station has one work, and that one work has to be done within that specific time. So whether that particular component can be fixed in that particular time, that has to be tried out. So this production tryouts happens probably around 6 months before the actual vehicle is being launched, and see what are the problems you face over there and try to solve that problem. Then there would be a lot of quality control which has to be maintained for internal as well as supplier components. So most of the manufacturing company, they are in very good relationship with the supplier. So they believe that the supplier, most of these components, they are never checked before it is being handed over to the manufacturing line. So the supplier makes a seat. The supplier would pack that seat, send it to the manufacturing line. The way the truck unloads a seat, the person in the actual OEM manufacturing line, they will just take the seat and put it in the vehicle and tighten the screws. That's it. They will not be able to check each and every seat. So sometimes what happens is there would be a quality control team. They would take one seat in a day, or they would go with the pattern, so that they would randomly select one seat and check whether it actually meets the quality. Excuse me. So that is how. So the quality control is very important. So So Japanese manufacturers, how they are maintaining this quality is because they have a very good inspection system with the supplier. So the supplier, whenever they try to develop a supplier, they will give all the knowledge the OEM has to the supplier, so that they manufacture with the same quality what the manufacturer expects from them. So, and there would be quality control engineers who would be visiting their facility and make sure that they follow all the standards, all the components are very well made, and then only if there is any rejection, they are rejected, and then only good components are sent into the manufacturing facility. So, like you might have seen that a lot of vehicles, brand new vehicles, they might come up with some sort of failures. It may not be the actual fault of an OEM. This component might have come from another supplier. They fitted this vehicle. That supplier might not have made that part very well, and that could be the reason why the part actually failed. But the responsibility always lies with the OEM. So that it is a responsibility of the quality control engineers in the OEM to make sure that all the component which is reaching the manufacturing line is within specs and they are made of the best qualities. Then there is a stage called pre-production. Like I said before, the pre-production is you do a production test tryout, and they would be made in small batches. Like say 10 vehicles would be made in one day, and see whether what are the issues they see during this pre-production. Some pre-production vehicles are sellable, so sometimes you might see that there would be an employee discount and given to employees. So these pre-production vehicles, they will have, or most of they would be as good as a start of production vehicle, but they would be made before the actual production starts, and they will have most of the components production ready. Sometimes the company sells these vehicles to the employees itself, or sometimes they use these vehicles for their fleet. Like say you might see that they will have their internal vehicles. So these pre-production vehicles are used for for the purpose of the company itself. Then there is mass production. Mass production is when it starts the actual production. So most of the Indian manufacturers, what they do is they will do the start of manufacturing much before the start of sale. So like say if you are planning to launch a vehicle in June, the start of production SOP would be somewhere in March. So these 3 months they would make as many vehicles they have, keep it in stock, so that when the vehicle is launched in the market, everybody wants that vehicle. So to give more vehicles at that time, they will keep them in stock. And sometimes the manufacturing has a delay of almost 1 month. By the time the vehicle is actually made and reach the dealer, they would take months. So they would always start this production much before, and then probably after 3-4 months only the start of sales happens. So I think that by that we are almost at 4:30. So I would like to wind up my presentation here. If you have any questions regarding this topic, please go ahead and ask. I will try to give the answers as best as I could. If not, you don't want to ask right now, you're shy, you want to ask me personally, feel free to send an email to my email. It is very simple, Don Kurian, my full name, @gmail.com. Please go ahead if you have any questions.
Okay, thank you, Don. So we'll give you a minute to catch your breath and have a drink of water. Students and faculty members, if you have any questions, the floor is now open to anyone who has any questions. Please unmute your mic or raise a hand and unmute your mic, and you can go ahead and ask a question, or you can paste your questions in the chat box. So just to get the ball rolling, maybe I will be the first person to ask just a small question, if you don't mind, Mr. Don.
Sure. Yep.
So now you are actually a professional now working in the automotive industry. So I want to know, when you were right now in your current position, what is a tool you think would have been useful, the knowledge would have been useful as a student and given you an edge when you joined, when you were starting your career? Have you thought anything like that? Is there this tool, if I had learned it during my college days, it would have given me an edge in getting a job?
My suggestion would be the SAE Baha formula students, because I know companies like Mahindra, Tata, they recruit a lot of people I had a lot of batchmates who had joined with me in Mahindra from these projects. So what happens is when you go and join in SI Baha or FA Formula students, you get an exposure. You have to actually develop a vehicle. You have to do engine calibration, you have to do design, you have to do development. So you are actually going through a mini project of an actual vehicle development. So this so people who goes through these sort of projects, they will definitely get an exposure how an actual vehicle is made. So that is one good tool which I would say if you have the time and facility. I believe you guys might be already doing that. So that is one good thing where you could start looking into it. And then always try to learn more skills if you get an opportunity, like say simulation softwares, CAD softwares. These especially in US right now, if you look, the most important field, I know America has been started developing vehicle long back, but the engineers, most of the Indian engineers who work over here, they are mostly working as software developers. So most of the software engineers working in US for vehicles are Indians. And then you have autonomous vehicles, electric vehicles. These are the field where you have a lot of programming, software coding. So there is opportunity for Indians across everywhere. Even in India you have opportunity in all the fields. But even if you want to go abroad, software side is really good. Then you have CA. CA is computer data engineering, vehicle simulation, a 3D model and simulation of these models. That is also a field where we as an Indians, we have excelled really well. The field where I work, vehicle testing, is a very difficult, tough field. I got an opportunity back in India. That's the reason why I still have a job here. But it is a little tough field. But again, if you want to be in India, that is a really good opportunity as well. So I would advise you guys to be part of SA Baha for students, all those student projects. Be part of that. Whenever you get an opportunity to do your dissertation, don't make any just like any project. Just be serious with the project work you are doing. Try to talk to somebody in industry and develop a dissertation project, like your final year project, which will make sense for any automotive industry person. So there would be recruiters coming from industry, and there would be technical recruiters, as well as there would be HR interviews. So, but if you have a project which is very relevant to the current market, that would also be a good learning for you guys. Because I know, we have a set curriculum, but these are the few things where we get a chance to learn beside our curriculum. So make sure that you have that opportunity. You make sure that you really make use of that.
Okay, thank you, Don. Is there any questions from the students? So I hope I got the ball rolling. Does anybody have any question related to the development process of a vehicle? And so now he's also mentioned about the Baha competition and CAD software. So if there are any questions, you can ask him right now.
So, Coach sir, I have to ask you a question.
Yeah, Manu sir. This is also another faculty of ours. Go ahead, Manu sir.
Sure. Yeah.
Thank you, Don. Thank you for the session. Actually, it has been an informative session for us. So I want to ask, what are the processes followed by the OEMs in introducing a facelift model? Can you explain in short?
Introducing a facelift model. So mostly when you come up with the facelift is when your sales go down or you have a very good competition from some other customer. So facelift model, the problem is most of the dies, like the sheet metal part, dies are very expensive. Like I believe, one panel die for a panel would cost around 3 to 4 crores, and most of them are imported. We don't have much very good tool making facilities in India. So, but one simple thing you could change is all the plastic parts. So, like say headlight, grill, the bumper, you could change it. That is why most of the manufacturers, when they go with the facelift, they will not touch the sheet metal parts. They will only touch the plastic parts. So it's mostly based on the budget you have for the change. Sometimes you will get a massive budget of around 300 crores. Then you will have an option to develop a new engine, new suspension, improve brakes, new multimedia system. You will have that option. Sometimes you will only get around 50 crores for a facelift. So if you have 50 crores, then probably you would be able to change only the grill and the bumper and maybe the headlight. That's it. So it all depends on the market dynamics and how the senior management in the company thinks. Okay, what all changes has to be. Just for your understanding, I'll tell you the original Thar, which was made back in 2010. Which was launched in 2010. It was actually a makeshift product. It had a Bolero engine. It had a suspension from Bolero and Scorpio. So that project was initially made for, I think, less than 5 crore rupees. But it was a very huge success. The vehicle sales were less than 500 vehicles a month. So, you imagine, you spend 5 crores, you develop a vehicle, you sell 500 vehicles a month, and you sell that for 7 years. It is very, it is a very good process. So always the ideology is to make more money out of the program you have. Sometimes it becomes a failure. Sometimes you spend a lot of money and then the vehicle doesn't kick off.
Thank you. One more thing I had to ask you. Actually, I'm asking on behalf of students. I have got this question from students before. That's why I'm asking. Actually, as a automobile engineering students, I think you have almost answered the question. But I'm asking it again as an automobile student, how he can develop a career in sports vehicle development. I mean, how can be part of a racing team or like that? You are an expertise in sport vehicle technology, right?
I am actually not an expert. I had a degree in motorsports. I was really passionate about it, but I never got an opportunity to actually work in motorsports field. But my advice would be, India has some motorsports companies in it, like say Hero has a motorsport team, TVS has a motorsport team, Volkswagen has a motorsports team. So there are a couple of teams who is actually manufacturing automotive team. Mahindra has this Mahindra Great Escape. There is a team which actually works on that. So Mahindra Adventure team. So there is teams within companies which they specializes in motorsports. But it is a very tough field in India. Especially India has motorsports is not as popular as say it is in US or in England or in Europe, how it is in India. So it is definitely very tough. My suggestion, if you would like to be in that field, would be talk to the Instagram pages of say TVS Racing. I've seen a couple of inquiries over there. So the people, they would message the TVS team that I have been you should just say I completed my BTEC and then I wanted to be in racing. It may not be possible. So you try to showcase your your achievements and then message that I'm really passionate about motorsports. I would like to be in your team. So it may not be as fruitful. You may not get the salary what you would expect from an OEM in motorsports. They definitely pay you very, very less because they have limited budgets in motorsport team. But you could you could talk to them, try to make contacts through social media, and look for an internship, say for a 6 months internship, and see how that actual field works. And if they like you, you like them, try to work out once you get into that. But again, you can look for people through social media like LinkedIn, Instagram, talk to them and see whether is there any opportunity. But you will hardly find opportunities like job postings for roles in say any website for motorsports. It is a very you have to talk to the people, right people, and get a job. They don't normally advertise it. They always try to find the person by themselves. So it is a very difficult field. I still didn't got an opportunity. I was not successful in getting that opportunity. But I definitely wish you guys they really try your level best. And if you really want to be in motorsports field, there are opportunities. But yeah, give it a try and see if that is possible.
Thank you very much.
So, is there any questions from any of the students?
Hello, sir.
Yeah, we have one question from Akshat.
Yes.
Go ahead, Akshat.
So my question is that now there's a huge change from conventional vehicles to electric vehicles. So, what do you say about the changes in design process from?
So there is so not till now, maybe till when the Tesla actually came up with their Model S, I think till then people were mostly developing electric vehicles based on their internal combustion engine platform. So you have the Chevrolet Cruze. All those vehicles were actually a conventional engine vehicle. Then they have been converted to electric vehicle. But Tesla is one of the early competitors in the field who were successfully developed a vehicle from scratch, and then they were successful in market as well. So now the trend, especially in US, I am not sure in India still there is a lot to catch up, but in US there is a huge change going on right now. So now all the new opportunities you will find is mostly in electric vehicles here. Electric vehicles and autonomous vehicle is the next big thing. So especially if you're looking for a job opportunity in places like US or Europe, I would definitely ask you to start looking in electric vehicle drive line. There are so many requirements around here for engineers because so many new startup companies have started. There is Rivian, there is Zoox, there are so many Lordstone Town. There are so many companies around here. They are mostly based in California. I work in Detroit. Detroit is the traditional automotive manufacturing capital, whereas in the California is where all the new electric companies are going on. But there are so many companies right now, and there are so many new models. I believe there would be within the next 2 years. There would be a lot of people buying electric vehicle as well. Right now, even I started thinking of buying my next vehicle as an electric vehicle because the infrastructure is getting improved right now. And if you can owning an electric vehicle, there are so many incentives in US, and that you don't have to pay for fuel. Fuel is very cheap in US, but still, when you consider thinking the fact that you're going electric, that's going to be really much cheaper than what buying a gasoline vehicle or diesel vehicle. So yeah, changes are happening. I think maybe in next 5 years there would be a huge shift. Maybe in next 10 years, 50-50. Maybe next 10 years, yeah.
My name is Melvin C. Joshi. I am pretty much interested in motorsports, and when I finish my BTech engineering of automobile, I want to pursue motorsport engineering. So how do you proceed about it? I mean, you also went to a motorsport engineering course, so I'd like to know more about it.
So the motorsports engineering course, if you want to go for higher studies, especially England is one of the best places. There are a lot of universities in England which does masters in motorsports engineering. One difficult problem about England is that England, the opportunity to get a job after you complete a motorsports engineering is very difficult. But especially if you work in an industry like an OEM for a couple of years, and then you are really good in simulation, aerodynamics, and then you go to motorsports engineering course, and then you apply for a job, probably you will have a better chance. So my recommendation would be, get some experience within India, if possible, and then go and pursue this higher studies. So you would be much successful. I think there are a couple of good companies in India, like TVS Racing. There are a couple of opportunities in Coimbatore, I think. So these racing teams, if you after your graduation, you can talk to these teams and find out if they are ready to take your internship. If they are ready to be with them, even if they don't pay you, work with them for 6 months. Keep looking for other jobs. That experience for 6 months definitely will help you get a job somewhere else. So yeah, that is a way you can try.
So if there are no more questions, I'd like to hand over the mic to Jaydevan sir, who will be proposing the vote of thanks. And so Jaydevan sir.
Yeah, am I audible, sir?
Yes, go ahead.
Hello. Yeah, it's very good afternoon, dear colleagues and my dear students. And my job is to give a vote of thanks to this event. To be frank, with immense pleasure I am doing that, because our guest, Mr. Don, gave a very wonderful presentation and very informative presentation, which will help our students and give valuable advice to the students also, where they have to pursue their extra studies, that is points outside from the curriculum. That was very wonderful, Don, for that advice and your presentation. presentation. And I would like to thank the whole SSST family, Principal HOD Manoj Kumar sir and Koshi sir, Amal sir, for the support to conduct this event. Without their support, it may not be possible to know all these things within one hour. 1 hour. Okay. I also thank all the participants who participated in this event and made it active. In fact, asking questions and all, and made this event a great success. Once again, I thank each and everyone present here, and thank you very much. No.
Thank you, Jayant sir. I would like to share one video which I was supposed to share it during the presentation, but I forgot about that. So this is a video about a testing center in. Everybody, all the people are really excited about, especially students. They are really excited about testing. So how the testing happens. So this is a test facility in Spain. It is called IDIADA. I would like to share that video, and and once again, thank you very much for being in this, being a part of this presentation. Thank you very much for giving me this opportunity. I'm really glad to interact with the students, and it is always a pleasure to tell, because when I was there, when I was an engineer, I was always looking for sessions like this. Talk to industry people. So yeah, I'll just share this video, and then if you guys want to stay, please stay. If not, you're good. There is nothing more I'm going to talk, but just the video. Yeah. 1 minute.
So as Mr. Dominic is loading his video, the feedback and certificate link is shared in the chat box. Please be careful when you are entering your email ID. Please enter the correct email ID, and your certificate will be generated and sent to your email. Okay, go ahead, sir. Yeah.
It's a little slow. So these are proving grounds. Like all the OEMs, they take the vehicle to proving grounds for their testing. So this is one. This is a very popular test proving ground in Spain. This is a high-speed track where you check the vehicle for their high-speed performance. This is a track where you look for braking, wet performance. So this is where you will. These are off-road tracks. This is where we do all the steering testing, so these are very wide, big areas where we go and do steering testing, figure of 8. So I know there's so yeah, just wanted to share this video. If this motivates, if somebody wants to go and become a test engineer, just being a motivation. All right, thank you.
Yeah, thank you very much, sir. So you can go ahead and log out. And the students, thank you all for patiently bearing with us. So thank you all, and everybody stay safe.
Thanks for this presentation. Yeah, okay, sir.
Thank you all, and stay safe. Thank you, Mr. Gaur.
കോച്ച് സാറേ.
Yes, sir.
സാറേ നന്നായിരുന്നു
Yeah.
സാറേ.
Yeah.
താങ്ക്സ്.
Yeah.